Hey there! Great to see you again. Today, we will delve deep into one of our most fundamental ways of expressing ourselves. We will talk about written language. And we will talk about how we can teach an AI to understand written text and make sense of it. The topic is called natural language processing. Alright, all of us have been there. We needed help from some company support team. And all they offer us is a chatbot. We all know chatbots, right? Some of them are so awful that there are even memes about it. But some are actually really impressive. We all know ChatGPT by now, OpenAI's famous chatbot that can talk about almost anything. From basic questions about daily life's mysteries to programming and maths questions. But how does that actually work? How is an AI able to read our messages, understand them, and give an educated answer? Lucky for us, the resources to do it ourselves without paying a dime are readily available online. That means, in the end, I will share some frameworks you might want to check out to try it yourself. But for starters, we are all but a tiny chicken that has no idea where to start. All we know is that there is input in the form of text, and we want to learn how to make sense of it. So, where do we begin? How about we start with the most intuitive approach? We split the words after every white space. And guess what? This is exactly the most fundamental step in comprehending this topic. This step is called tokenization. And the result will look like this. Here we also already see a feature of modern frameworks that is extremely convenient. They detect exceptions like can't and split them into two words, can and nt, or not. But at the same time, they are aware of expressions like UK, which are not meant to be separated. Like this, we have a solid foundation to extract information from our sentences. The next step would be to involve models. Models are more or less different brains for our AI. Depending on the context, we can switch them to ensure a pleasing performance. Here, we will take advantage of models that have already seen thousands and thousands of sentences before, and thus have a fundamental understanding of the language. This does also include the statistics about it. For example, how likely it is for a specific word to occur after another specific word. Or in general, different types of words and their probabilities. For example, it is very likely for a new word following the word the to be a noun. If you are not sure, nouns are the names we give very specific things in the real word, like table or video or happiness. And if you now think of the words that come to your mind first when you want to say something that starts with a the, it will be words like apple or house or robot. All of them are nouns. There are other categories too, like adjectives or prepositions, pronouns, and so on. Detecting these categories in our sentences is called POS tagging. Here, POS is an abbreviation of parts of speech. The interesting aspect is, each of these categories has a different probability of occurrence than the others. For example, it is more likely for an adjective like red to occur before a noun like strawberry than a preposition like to or at. This is an example easy enough to understand intuitively. Because if I show you these expressions, you too will say, the latter ones don't sound right. And our AI will keep all that in mind to calculate more accurately what might be the next word. Or at least what might be the next type of word. Another technique of dealing with text is the so-called stemming. This technique reduces the word to its roots. In this example, we see a few variations of the word discovery. We see the word itself, discovery. The plural of it, discoveries. The verb, discover. the conjugation of the verb discovering. But all of them boil down to the same root, and that can help us. So if we apply stemming to our sentence, the result will look like this. Here we see that the words are a lot more similar than before. This already helps us in grouping similar words. But obviously, there are still some differences between them, so we are not yet done. And while trying to fix this, scientists came up with a smoother idea how to tackle this obstacle. This idea is similar, but gives words that make sense on their own instead of just a fragment of a word. I am talking about the so-called lemmatizing. A lemma is a word that represents a whole group of words. That group is then called a lexeme. Sounds strange, don't you think? Let's get there step by step. Have you ever looked something up in a dictionary? There we usually don't look for the exact word we don't know, but rather the root word. For example, if you don't know the word discovering, but you do know how the English language works, you immediately jump to discover and derive the meaning of discovering from it. That means discover is our lemma and discovering is part of our lexeme. With this, we reduce whole sentences to their core, and this facilitates the comprehension for our AI. Now that we have understood how to separate words, categorize them, and identify their core, how about throwing them together? The technique is called chunking and is used to identify phrases. To clarify that, a phrase is a group of words that work as a single unit. For example, we can add adjectives to a noun, and now they are a team, grammatically. But to do this, we need to make use of the POS tagging. You remember, right? We categorize words by their function in the language. If we take this sentence of a really famous franchise and let our AI take a look, we see that our AI established a system in our sentence. It split up the words into their different functions in our sentence. For example, it is a preposition, therefore it says PRP. VBZ means verb, JJ stands for adjective, and so on. If you are curious, I will put a link with all the tags and their meanings into the description. But let's get back to our original topic, the chunking. In this example, we see that a dangerous business was recognized as one united expression. That means our AI indeed understands phrases and can handle them appropriately. This by itself might not be very interesting for you, but hang on for a second. Because the next technique uses this knowledge about chunks and searches for them in a long text. A whole book, for example. To demonstrate this more vividly, I will show you an example where we search for the occurrence of the word cat. And as you see, this gives us an insight of the context where this word was used. If we now feed an AI with lots and lots of snippets like this, it starts to figure out how to use this word authentically. This is called concordance. With this, our AI now has a broad idea in which context it is ought to use our words. How about we also find out which words are the most prominent ones? With this, we could evaluate different contexts more efficiently. And this is called a frequency distribution. The idea is pretty straightforward. We go through the text and count all the words. In the end, it will look like this. With this plot, we can also start to analyze if some words in general appear together more often. This is called a collocation. It is pretty fun to dive deep into the metrics of your text and start to see patterns and hidden information. And if you know what to say, that is overwhelming for me. I don't know where to start. Let me tell you that there are already powerful tools to make it easier for you. The first I want to share with you is the Python's NLTK package. NLTK is short for Natural Language Toolkit, a box of util functions, so to speak. On its website, everything is explained in a detailed and understandable way. Give it a try, it sure is useful to get into the topic. Another one is SpaCy. It is an open-source software library for natural language processing. It is pretty powerful and offers some great tutorials. Everything for free. And to end with something more advanced, Facebook did also release their BERT model. You can download it, use it, or train your own model based on it. It is a bit less user-friendly, but once you get the hang of it, you can build quite impressive applications with it. And this is it for today. Hopefully, you learned something new, and if you are interested, I uploaded some more videos. Partly about applications like computer vision, and partly about the fundamentals of machine learning. Check them out if you are curious. Either way, thanks for watching. Ciao!